Hello, people. Good morning. You're all doing good. Very less number today. I'm seeing only 5 of you. Maybe we'll wait for maybe 2 more minutes. Let's see whether your friends join or not. Right? So, in your school, in chemistry, acid base and salts are completed this chapter for you.
Almost completed, sir.
Almost completed. Okay. Aditi says yes. Okay, I think some of you are from different schools. So for Aditi's school, I think I've completed. I have UT, that is unit test 2. Okay, fine. Unit test 2 tomorrow. Yeah, which chapter? This chapter, Aditi? Acid base and salts. Okay, fine. So yeah, so today's class will be a little helpful for you then. Right. Yeah, Harika. Good morning. Well, for 9:33 we'll start. We have 7 people. It's 1 more minute. Is there anybody new? I mean, Arman, are you new, Kanna here? This name I'm not seeing, Arman. Are you new to the class? Arman, are you there?
Sir, Atharva is new, sir.
Who's new?
Atharva.
Atharva.
Yes, sir.
But I don't see that name here. It's not
Sir,
here
he
today.
hasn't.
Okay. Fine. Anyways. Okay, I think we'll start. Right. If all your friends will join, they will join. Let me share the screen. Okay, so last class, hope you all remember what we saw. We'll just have a quick recap of whatever we saw last class and then we'll continue. Okay, so we started with what is the definition of an acid or a base, right? So we saw 3 concepts. So there's Arrhenius concept, right? It says, well, something is dissolved in water. If it gives me H plus or H3O plus, I told you how H3O plus. What is the name of this H3O plus ion, guys? What is the name of this H3O plus ion? Anybody remember? What is the name of this H3O plus ion?
Hydronium ion, sir.
Right, hydronium ion. Right, good. Anyways, so if I produce H plus or if I produce H3O plus, when that species is dissolved in water, then it's called an acid. The same thing, if I dissolve something in water and I produce OH minus, and you all know it is hydroxide ion, right? Then it is called a base, right? Now we moved on to other concepts, even though it is not required for you, but just for the knowledge understanding. We went on to see okay, I told you how this H3O plus ion is formed. You can see HCl is an acid if it dissolved in water. Now, please understand, not only in this reaction, people, any reaction where an acid or a base is involved, right? Say if something is capable of giving me H plus, there should be something there should be something along with it, right? There should be an acid which is capable of giving me H plus, and there should be something else in the solution which will be able to accept this H plus, right? So there should be H plus donor as well as the H plus acceptor. Not only in this reaction, for any reaction for that matter, this should be happening, or else there is no reaction. Okay, right. So now this H plus coming from HCl will attack this H2O, and then H2O plus H plus will form H3O plus, and what is remaining is Cl minus. Okay, I told you this H plus is not going to be that stable, right? So this H plus is very, very unstable. It is highly reactive. It will react with the water molecule to form H3O plus. This is quite stable compared to H plus ion. Okay, right? And then we moved on to the next concept, that is Lowry-Bronsted theory. Now, why we went on to Lowry-Bronsted theory is because there are certain species which doesn't give me H plus or doesn't give me OH minus, but still they are regarded as acids or bases, right? So in that case, we said that whichever is able to donate a proton, P plus is a proton, right? Whichever is able to donate a proton as an acid, and whichever is able to accept a proton as a base, right? Now, proton is very simple, right? H plus is a proton. Because hydrogen, if I take hydrogen atom, it contains one electron, one proton, right? Now from hydrogen, I remove an electron to form H plus, right? So one electron is gone. So what is remaining in H plus is nothing but a proton. Okay, so obviously anything which gives me proton, right? Donating a proton is what is an acid. Okay, that's fine, right? Now which is able to accept a proton or accepting H plus, you can understand. I think I wrote the reaction here. See, NH3 is a base, ammonia is a base, which accept H plus to form NH4 plus. I know the name of the ion is an ammonium ion. See, this accepts H plus. So this is going to be a Lowry-Bronsted base. Okay, right? Then we moved on to Lewis theory, right? Which says in terms of electrons. Maybe I generally told you that we generally don't speak in terms of proton movement. We generally speak only in terms of electron movement. Right? There are various reasons for this, because electrons are smaller, electrons are having lesser weight, so they will be able to move easily when compared to a proton. Okay, so now whichever is able to donate, where is this? Yeah, so whichever is able to donate, donate a pair of electrons are what are called as bases, and whichever is able to accept a pair of electrons are what are called as acids. Okay, and then we went on to see some examples. If you're interested, you can look into it. I told you how this can BeCl2, BF3, how they are electron deficient species, right? Hope you all remember beryllium. If I have to just take 2 minutes, right? Beryllium has atomic number of 4, so it will have 2,2 configuration, right? There are 2 chlorine atoms here, each will give 1 electron, so the configuration will become 2,4. But still, this is not stable, right? Because I require 8 electrons here, but still I have only 4 electrons. So now this BeCl2 can still accept electron to be a Lewis acid, which are able to accept electron or what are called as Lewis acids. Okay, same goes with BF3, 2,3 will be the configuration. 3 fluorine atoms will become 2,6, still after not satisfied. So again, it can accept. Okay, right? Then we went on to see what are these lone pairs. Okay, but not important. Anyways, then we went on to see what are the physical properties of acid, corrosive, sour, they form aqueous solutions, they turn blue litmus red, they have a pungent smell, all that. And then we went on to see what is the classification of acid, right? First is based on source, where we get it from. First is organic, that is natural, and the inorganic, which are synthetic acids. Or it can be even semi-nature, semi-synthetic, or semi-nature means the starting material will be something else, but I reform it or synthetically prepare it to something else. Starting material is from the nature, something like that. Okay, and you have to know the names of the acid people. HCl is hydrochloric acid, HNO3 is nitric acid, H2SO4 is sulfuric acid, H3PO4 is phosphoric acid. Okay, then we had a list of organic acids, where citrus acid is from citrus fruits, tartaric acid, tamarind, all so on and so forth. So many acids we saw. Okay, and I told you the moment you see the COOH, that is the functional group. Okay, in all these acids, all the organic acids which you see here, right? This COOH will be common, right? For example, acetic acid is CH3COOH. Formic acid will be HCOOH. I told you for oxalic acid how it looks. Yeah, oxalic acid is COOH. You can see this COOH is common for all the organic acids. Okay, I think this is where we stopped last class. Any questions till now, people? Anybody has any questions you want to ask me till now? Okay, I suppose there are no questions. So today we'll move on with our class. We'll continue. Right. So 10th, 18, 7. Right. Good. Right. So we'll continue. So, oh, not 1 second, guys. Okay, we escaped. Okay, fine. So we'll continue with the classification of acid. The first classification was based on source, where we get the acid from. Okay. Now, second classification is based on, say, we can call strength. Okay, based on strength. Right. Fine. Now, I think from the name itself, we can understand when I say strength. Okay, we'll see first. Okay, so based on this, based on strength of an acid, I will be able to classify them as in 2 types. One are what are called as strong acids. The other case is what is called as weak acids. Okay, strong acids and weak acids. Okay, now how do I determine whether the acid is strong or weak? Okay, now you have to remember this term, people. Very, very important phrase you have to remember is extent of dissociation. Okay, you have to remember this phrase. Okay, extent of dissociation. Now, please understand, any acid for that matter will have some, say, HA is an acid. Okay, HA is an acid. Okay, now this HA, I know it will be able to dissociate to form H plus and A minus. For example, if it is HCl, it is going to form H plus and Cl minus. Okay, now assume this is a normal general acid. Okay, now what do you mean by this extent of dissociation? This entire reaction is what is my dissociation reaction. You know what is dissociation, right? Breaking up. Right, dissociation means to dissociate. One thing getting separated into multiple stuff is what is called as dissociation. Right, now acid dissociates to form H plus and the counter anion. This is an anion. Okay, H plus and counter anion. This is the dissociation reaction. Okay, now how much this dissociation reaction is going to happen is the question. Okay, say for example, you take 10 grams of this acid. Okay, I'm just giving you a random number. Okay, you take 10 grams of this acid. Okay, now if you find after some time, right, say after some time, right, if you find that this becomes 0 and this entire H plus and A minus becomes 10 grams. Now, what do you mean by this? What do I mean by this is that this entire 10 grams of acid got dissociated to form H plus and A minus. Okay, so can I say this reaction, or I have 100% dissociation is happening? Can I say that? Because whatever the amount of acid I had initially, 10 grams of acid, that entire 10 grams got converted into H plus and A minus. Okay, now what I can say about it is that that particular acid is undergoing 100% dissociation. Okay, now understand, the more and more is the extent of dissociation. What do you mean by extent? Like how much it is happening, right? More and more is the extent of dissociation. More and more is the strength of the acid. Okay, now what I can tell about strong and weak acids is that strong acids will have almost 90 to 100% dissociation. I can even start from 7 or 80%. Okay, 80 to 100% dissociation. If you have this reaction completes to 80 to 100%, right, then it is a strong acid. Okay, so can I tell this particular acid which I took the case, can I call it as a strong acid? Right, because 10 grams I had, all the 10 grams got dissociated into H plus and A minus. Right, so this HA, which I considered here a normal line example, is a strong acid. Okay, but say I take some other acid, say I take some HB, right? Say it forms again H plus plus B minus. Okay, now I take 10 grams. Now, after some time, what I see is that 5 grams of this acid is still remaining. And obviously, that means what? Only 5 grams of this H plus and A minus are there. Okay, initially start with 10 grams. After the reaction got over, right? After the completion, what I see is that 5 grams of HB is remaining. And obviously the rest 5 grams has converted into H plus and B minus. Okay, so out of these 10 grams, only 5 grams are undergoing dissociation. That means I can say only 50% dissociation is happening. Okay, only 50% dissociation is happening, right? Now, obviously, that is going to be a weak acid, right? Why? Because when you have, say, 20 to 70% dissociation, I'm just giving you around, like, say, approximate numbers. Okay, so whenever you have 20 to 70% dissociation, that comes under weak acid. Okay, now you see only 50% dissociation is happening, right? So definitely HB is going to be a weak acid. Okay, so I told you more and more is the extent of dissociation, more and more dissociation is happening, more and more will be the strength of the acid. Okay, no issues till now, right? Okay, so we understood what are strong acids, what are weak acids, how do you determine whether something is a strong or weak acids, and that comes from this particular important phrase, extent of dissociation. Okay, right, fine. Now what now can be examples, right? For strong acids, people, the normal acids you all know, HCl, HNO3, H2SO4, H3PO4, all these comes under strong acids. Okay, now when I want to talk about weak acids, say acetic acid, CH3COOH, right? I have HCN. HCN is cyanic acid, right? HCN I can somewhere up, right? I'll make some space. HCN is called, or I can call it as hydrogen cyanide, or it's called cyanic acid. Okay, this is also a very weak acid. Okay, right? So 2 examples you can remember, that's enough. CH3COOH and HCN, all these are weak acids because they are going to have the dissociation in between this range, that is 20 to 70%. Okay, now all the other acids I mentioned this side, that is HCl, HNO3, H2SO4, H3PO4, all of them are good acids, that is strong acids because they have good extent of dissociation. They'll undergo dissociation to a larger extent. Okay, right? These are all the examples. Done. So that is about strength. Based on strength, how do you classify strong and weak acids? Okay, right, fine. Next, moving on. Any questions till now, people? Any questions about strong and weak acids? Anybody wants to ask me anything? Okay, I suppose it's very clear. Right, moving on. Third classification. Right, third classification is based on concentration. Okay, based on concentration. Okay, first we have to understand what do you mean by this term concentration. Okay, now I think the classification is very simple. I have something called as a concentrated acid and I have something called as diluted acid. This is the classification: concentrated acids and diluted acids. Okay, now before we move on to see what is concentrated, what is diluted, we'll spend some time on this term concentration. What do you mean by concentration? Okay, guys, now we all know in a solution, right? In a solution, we know the term solution, right? In a solution, there are 2 components, right? What are they? In a solution, the 2 components are what? What are the 2 components of a solution?
Solute and solvent.
Absolutely, right? I have something called a solute and solvent. Something called a solvent is there. Okay, now this concentration, when I say concentration, I am talking about amount of solute present. Amount of solute present. Okay, basically it can be, I can tell that say 10 grams of NaCl is dissolved in 100 grams of water, right? So the 10 grams, which I tell that 10 grams of NaCl is dissolved in 100 grams of water. If I tell you this 10 grams can be the concentration, very simple. Concentration just talks about how much amount of solute is there in the solution. Very simple. Okay, right. So now it's very easy for us to understand what do you mean by this then. right? So we are talking about acid solutions here, is it not? We are talking about acid solutions here. Obviously here the solute is the acid, right? Obviously solvent would be water. That's understood, right? Solute is acid and the solvent is water, right? Okay. Now, when I say concentrated acid, I'm going to have more acid, less water, right? And obviously in diluted, I'm going to have more water and less acid. Very simple. Okay, say if I give you a case, right? Assume that I have 10 grams of water in two solutions. Okay, 10 grams of acid is there in two solutions. Okay, now to this, you add, say, 5 grams of acid, and to this, you add only 2 grams of acid. Okay, now can you tell me A and B, if I take, which is concentrated, which is diluted, can you tell me? Did you understand the question? I have 10 grams of acid in both of them, both two beakers. I add 5 grams of acid in A and 2 grams of acid in B. Now with this data, can you tell me which is concentrated and which is diluted?
Sir, A is concentrated and B is diluted.
Absolutely correct, right? Very simple. In both the cases, I had 10 grams of acid, right? So whichever is having more solute, that is concentrate. Solute in the sense the solute here is acid, right? So whichever is going to have more acid is going to be the question. I mean, it's going to be the answer. So here I have 5 grams of acid, but here I have only 2 grams of acid. So obviously this is concentrated and this is little diluted. Okay, now see, this is a like concentrated and diluted, we cannot just tell directly, right? We can only compare and tell. Say if I give you two solutions, if I give you two acid solutions, right, you can compare these two acid solutions and then tell, okay, this is concentrated, this is diluted, right? But if I give you only one solution, right, now it is generally not advisable to speak whether it's going to be in terms of, you know, concentrated or diluted acid. It's not advisable to speak like that. But if you want to compare two acid solutions, right, then you can go for these terms, concentrated and diluted, right? And one more important thing is people generally confuse concentrated and diluted with strong and weak acids, right? Now, please understand, there is really no connection. I would say, at least for your level, right? Please understand that these are not same. Strong acids are not concentrated. Weak acids are not diluted. Please understand, it is not like that. Right? Now, concentrated and weak acid all just talks about the relative amounts of acid and the water present in the solution. But in case of strength, that is strong and weak acids, you know what is the criteria? The criteria is extent of dissociation. Okay, so strong acids, weak acids, concentrated and dilute acids are not connected. They are two different things. Okay, right? So now here is a famous question, right? Say I have an acid. Okay, now I want to dilute an acid. Okay, say I have a concentrated acid. I want to dilute it. Okay, now there are two ways of doing it, right? It's a very famous question. I think everybody will know the answer, right? There are two ways of doing it: adding acid to water or adding water to acid. There are two things, right? Which is correct? When I have to tell me. Yes, please tell me.
Sir, adding acid to water is correct.
Yeah, correct. Right. Now, please understand, people, this dilution process, right? The process of adding, basically making it diluted, the process is called dilution, right? So dilution is a process where it is highly exothermic. Okay, the process is highly exothermic. Means what? When you're going to add acid to water or water to acid, whatever it is, when you're going to go for dilution, lot of amount of heat is generated. Heat is going to come out. Okay, right? So because of that particular reason, it is always good to add acid to water. In the sense, what I'm telling is, you have a beaker full of water. Okay, this is beaker full of water, H2O. Okay, to this you add acid drop by drop. Right, to this you add acid drop by drop. Right, now you can ask me, sir, the same thing can be done like this also. Right, I have a beaker full of acid and I can add water drop by drop. Right, now both of them are exothermic. Right, both of them are going to produce a lot of amount of heat, but you see, water can act as a cooling agent. Is it not? We generally know water cools stuff, right? So water can act as a cooling agent. Okay, so it is going to act as a cooling agent, thereby suppressing the amount of heat, like little suppress the amount of heat produced. Okay, thereby it is safe to add acid to water than to add water to acid. This is going to have an explosion also. If you don't do it, like if you do this at a random pace, this might even cause explosion. That much amount of heat will be produced. Not like a bomb explosion, but still, no, a small explosion can happen. Right? Okay, so it is always better to add acid to water because water is going to act as a cooling agent. Cooling agent for what? Because the dilution process is exothermic, a lot of heat is generated, and this water suppresses the amount of heat produced, and this is how you are going to dilute an acid. By adding acid to water. Okay, right? I think everybody understood. Okay, that is what is based on concentration, concentrated acids and diluted acid. As I told you, these are not connected with your strong and weak acids. Right? Okay, moving on. The next classification, fourth, is based on basicity. Okay, it is based on basicity. Okay, now first things first, you have to understand what do you mean by basicity. Okay, now very simple people, basicity is nothing but number of H plus ions an acid can give, right? Okay, this is the, what is basicity? Basicity is nothing but the number of H plus ions an acid can give, right? So under this, I have say mono basic acid. I have say di-basic acid. Say I can have even tri-basic acid. Okay. Now from the name itself, you can understand. I told you basicity is nothing but number of H plus ions an acid can give from one molecule. Obviously, number of H plus from one molecule of acid. Right, number of H plus ions coming from one molecule of an acid. Right, say from the name which you can understand, mono means one. Right, so if the acid can give only one H plus per formula, per molecule, then it is called monobasic. If it gives me two H plus ions, then it is called dibasic. If it gives me three, it's called tribasic. I can give you examples for all of these. Right, what can be examples? Say for monobasic, can you give me any example which gives me only one H plus ion per molecule? Any acid which you know, which will give only one H plus ion? So many are there. Any one example? I'm still thinking. It's very simple, right? I told you number of H plus ions from one molecule of an acid. Say HCl can be an example. HCl, how many H plus it will give? Only one H plus and Cl minus, right? HCl is a very good example. CH3COOH again will give what? H plus CH3COO minus, again only one H plus. Say HNO3 will give H plus NO3 minus, again only one H plus. Right, so all of them you see are capable of giving only one H plus ion from the acid. Right, so all these comes under monobasic acids. Okay, Fine. Everybody understood? Can I get a yes from everybody? Understood how it is monobasic?
Yes, sir.
Yes, sir.
Yes, sir.
Okay,
Yes,
good, fine. So everybody understood. So now can you tell me an example for a dibasic acid? One example is there. Can you tell me what is that?
H2SO4.
Absolutely. H2SO4. Now what it will give? It will give me 2H plus SO4 2 minus. Very simple. Now it is giving me 2H plus per molecule of H2SO4. So obviously H2SO4 is going to be a dibasic acid. Okay, right? So if at all, one more example I have to give you. Oxalic acid. We know the formula, right? Oxalic acid is COOH, right? Both this H plus and this H plus can come out, right? That is also going to be a dibasic acid. This is oxalic acid. You can take oxalic acid, right? Okay, fine. Tribasic acid. Any examples? We have one example, which I already taught you.
So H3PO3.
PO4, right? Phosphoric acid. Okay. Tribasic acid example is phosphoric acid. Phosphoric acid is nothing but H3PO4. Now you can see all the H plus ions. Maybe I can make some space and write. H3PO4 will give 3 H plus ions plus PO4 3 minus ion. This is PO4 3 minus is called phosphate. I think we saw this phosphate in first chapter, right? Even though we didn't see any reactions as such, right? PO4 3 minus is called phosphate ion. Okay, so it is giving me 3 H plus ions. So it is going to be a tribasic acid. Okay, now you can ask me, sir, is there any acid which gives me 4 H plus ions? Yeah, it is there, but we don't have to go into details. When you go for organic acids and stuff, when you go to organic chemistry, then you'll understand. But generally, these synthetic acids generally will not be, more than 3 H plus ions from single molecule is very rare. Okay, so you can only know monobasic, dibasic, and tribasic acids, and along with the examples. Okay, right, fine. So now that's about based on basicity. Okay, done. Anything else is there in classification? I think that's it. Okay, four different bases by which we can classify based on source, based on strength, based on concentration, and the last one is based on basicity. Okay, fine. Now this we know. So we started with acids. We saw what are the physical properties of acids, what are the classifications of acids. Now we'll move on to see what are the chemical properties of acids. Okay, what are all the chemical properties of acids? Right? Okay, fine. First one, right? Reaction with or action on metals. Okay, we'll see what will happen if I react an acid with a metal. Okay, right? Now it is going to be very simple, people. Now see, all these reactions are going to be displacement reactions. Right? All these reactions are going to be displacement reactions. Okay, right? Now, very simple here. Say, for example, I take sodium. Sodium is a metal, no doubt about it, right? Sodium is a metal. If I react it with HCl, HCl is an acid. Okay, now can you tell me what are all the products here? I told you it's a displacement reaction. So what should be the product here? Na plus HCl will... okay, one is NaCl, then other one? What is the other one? H. Do we write H? Or how should I write it?
H2.
Absolutely. H2. This is how we write it. Okay. Now remember, people, whenever a metal... Oh God, 1 second, guys. There is something someone is selling here. 1 second. Okay, now it's fine. Right. So whenever you have a metal reacting with acid will form a salt plus hydrogen gas is always liberated. Right. This is also hydrogen gas will be liberated. Now, let me see. Does anybody remember how do you test the presence of hydrogen gas?
So the burning splinter burns with the pop salt.
Right. When you bring a burning this thing, matchstick, it will burn with a pop sound. Right. I hope everybody remembers. Anyways, so whenever you have a metal reacting with another, this is the general equation, whatever I wrote here. Okay. Metal reacting with acid is going to form a salt. You can see here the salt formed is NaCl, and I'm going to have hydrogen gas getting liberated. Okay. Now I'll ask you one question. If I have copper reacting with, say, same HCl, what are the products formed? Now, first tell me whether this reaction will happen or not. This reaction will happen or not? First, then we look about the products.
Yes, sir.
This reaction will happen. Okay, go into the chat box, people. I want everybody to answer whether this reaction will happen or not. Yes or no. Yes for it will happen, and no for it will not happen. Go to the chat box and put all your answers. I will see. Okay, one yes. Come on, everybody participate. Copper plus HCl reaction will happen or not? Okay, no from Harita, S from Sanyu Kumar. Okay, come on, everybody. Just go to the chat box and type yes or no. Okay, Vaishnavi says yes. Amrita says yes. Man says no. Okay, that's it. We still have people, I guess. Come on, everybody, participate. Fuja says yes. Fine. Okay. Actually, the answer to the question whether this reaction will happen or not, no. This reaction won't happen. Okay. So minority of people only said, only 2 people said that the reaction won't happen. Any reasons can you come up with why this reaction won't happen, people? Why this
Because
reaction
copper is
happen?
below hydrogen in reactivity series, sir.
Absolutely true. Very good. Very good. So copper is less reactive than hydrogen. I told you that for displacement reaction to happen, not only this displacement, any displacement reaction to happen, the thing which you have here should be more reactive than the metal you have here. Only then this can displace this, right? But copper is less reactive than hydrogen. So this reaction won't happen. Okay, this reaction won't happen, right? Okay, say same thing will happen if I put gold or silver. This is silver, Ag is silver, Au is gold, plus any acid. Again, there will not be any reaction. The same reason, because gold and silver are less reactive than hydrogen. The same thing, right? Okay, now what I want to tell is that, but still, if you want to purify gold or silver, okay, if you want to purify, basically they will not dissolve in anything. Okay, this is gold and silver. Okay, they will not dissolve in anything, right? Why? First question, why do I have to dissolve? Right? Why do I have to dissolve gold or silver? It will be in solid form, right? Right. For example, when I mine it, obviously you know where we get gold or silver from. We are going to get it from the ground, from the fossil fuels. Right? They have something called as gold mines, silver mines. So obviously, whatever you get from those mines will be in solid form. Correct? Will be in solid form. Okay. And obviously, it is going to contain a lot of impurities because it is going to come from the ground. Right? It is going to contain a lot of impurities. Okay. So for me to remove the impurities, Okay, for me to remove the impurities, removing impurities from the solid state is very difficult. Please understand. Okay, removing the impurities in solid state is very difficult due to so many reasons. Okay, but if I can dissolve that particular gold or silver, mined gold on silver in something else, if I can dissolve it, then removal of impurities is very easy. Okay, now, but we know what is the difficulty here. If I want to dissolve silver or gold, it will really not dissolve in anything. It will not dissolve in water. Now, since they are not reacting with acid, they will not be able to dissolve in acid also, right? So what should I do? Okay, so for that, scientists came with an idea. Okay, now they prepared a liquid called as aqua regia. Okay, they prepared a liquid called as aqua regia. Okay, now aqua regia is what? Now this aqua regia is capable of dissolving gold or silver. Okay, this aqua regia liquid, right, is capable of dissolving your silver or gold. Okay, now what is this aqua regia? Aqua regia is nothing but a combination of acids. Okay, aqua regia is nothing but a excuse me. Aqua regia is nothing but a combination of acids. Okay, now it is going to be HNO3 and HCl. Okay, it is going to be nitric acid and HCl, and the ratio should be 3:1. Okay, 3 parts of HNO3 and 1 part of HCl mixed together. That particular mixture is what is called as aqua regia. Okay, and this aqua regia is capable of dissolving your silver or gold. If you take normal acid, this won't happen. They will not dissolve because it will not react. Okay, but if I take aqua regia, that is 3 parts of HNO3, 1 part of HCl, it is capable of dissolving silver or gold. Okay, I think this will be a this question keeps on coming in board exams. What is aqua regia and what is it used for? And they will ask, what is the composition of aqua regia? You must tell HCl and HNO3 are used, and you have to use 3 parts of HNO3 and 1 part of HCl. That you have to mention in the exams if they ask you this question. Okay, right? Fine. Now let me give you one more reaction, and then we'll move on to the next one. Say I have magnesium reacting with H2SO4. I want to know what is the product. Go for it. Yeah, what is the answer here? What are the products? Magnesium reacting with H2SO4.
MgSO4 plus H2.
Absolutely. Right? Now, very simple it is. I have MgSO4 plus H2 gas is liberated. Okay, one more. Say if I ask you, say lithium reacting, okay, lithium. Say I take, okay, sodium itself, sodium reacting with H2SO4. Now what will be the product?
NO2SO4 plus H2.
Yeah, right. So it's very simple, guys. So you have to understand what is the ion present here. The ion present is sulfate ion. You have to know this. Okay. Now, if you know the ion, then it is very simple. The salt formed in this case is magnesium sulfate, and here it is going to be sodium sulfate. Right. So you should not be writing Mg is there, SO4 is there, so it's MgSO4. Like in this case, it comes out like this, but in this case, it won't come. You cannot write it as NaSO4. It will be wrong, right? Because I know Na plus and SO4 2 minus will be there, so you will swap to form Na2SO4 plus H2. Yeah, be very careful. Okay, even though it's just a displacement reaction, but you have to be very, very careful. Like you have to know what is the ion here, what is the ion here, then swap, then get the formula. Okay, right? Fine. So that is about part of the first one is action on metals. This is how it reacts with metals. Metal plus acid will give you some salt plus hydrogen gas will be liberated. Okay, right? What is the time? We have time. Right. Next one is action with or action on. What I can tell, okay, action on metallic oxides. Okay, action on metallic oxides. Okay, now actually I thought I'll tell you about this when we go for bases, but now you can actually understand. Now please understand, people, metallic oxides, okay, I'll write here. Metal oxides are basic in nature. Okay, and non-metallic oxides are acidic in nature. Okay, now how do I prove this to you is the question, right? I'm telling you, okay, non-metallic, oh fine. Non-metallic, I mean, metallic oxides are basic in nature. That's what I'm telling. Okay, now how? I'll prove it to you like this. Okay, now look at this. Say I take any metal oxide, say I take Na2O, sodium oxide. Sodium is a metal oxide, oxygen is there. Okay, now sodium metal, when I try to dissolve it in water, okay, when I try to dissolve it in water, what will you see is that you are actually going to form NaOH. You are actually going to form NaOH. And obviously, this NaOH is already present in water only, right? So obviously, it is capable of giving me OH minus ions. So what I'm trying to tell you is that indirectly, Na2O or any metal oxide for that matter is capable of giving me OH minus ions when dissolved in water. Okay, that is why we say metal oxides are basic in nature. Okay, metal oxides are basic in nature. Very, very important. Okay, not only this, any metal oxide you take, MgO, same thing will happen. MgO plus H2O will become MgOH twice. Again, this is capable of giving me OH minus. Okay, so any metal oxide you take, okay, any metal oxide you take, I am going to have OH minus ions produced, and that's why I'm going to call them as basic oxides, right? Or metal oxides are basic in nature, right? Okay. Or another way of proving it is, now we know that I have something called as a neutralization reaction, right? I already know this, right? I think they must have taught you in school. Very simple. Acid plus base is going to form a salt plus water molecule is there, right? This is the normal neutralization reaction, a reaction between an acid and a base. Okay, this they must have taught you in school. Okay, right. So when I have an acid, right, and the base, if I use it as a metal oxide instead of a direct base, okay, if I use a metal oxide and if it gives salt and H2O, then also it is a proof that metal oxides are basic in nature. I hope you understand what I'm trying to say. If I have an acid and a base, this reaction will happen, no doubt about it. Right. So we know what are all the base. Generally, we use base as sodium hydroxide, magnesium hydroxide, like that we use. Okay. Instead of that, if I use the base as the metal oxide itself, right? Obviously, if this reaction happens, then that is also proof saying that metal oxides are basic in nature. Is it not? One way of proving it is by dissolving it in water. Metal oxides are basic in nature. One way of proving it by dissolving in water, you produce OH minus ions. Other way is to go for a neutralization reaction with an acid, and if it forms a salt and water, then again that proves that metal oxides are basic in nature. Okay, and that's exactly what we're going to see here in this action on metal oxides. When acid reacts with metal oxide, what is going to happen? So I can give you the general reaction: acid plus metal oxides are going to give salt plus water is going to be there. So don't you see, it is just like a neutralization reaction. Instead of the base, but I use a metal oxide here, and metal oxide is a base. That's what you need to understand. Okay, so if I have to give you any example, say I have acid HCl reacting with, say, sodium oxide, right? It is very simple for me now. The salt found will be NaCl, Na and Cl, and the other part will be H2O. Very simple. The other part will be H2O. Very, very simple reaction. Right? Okay. One more example. We didn't take any nitric acid example. Say I take HNO3 plus calcium oxide. Now go for it. Complete the reaction, people. HNO3 plus calcium oxide. Tell me the product.
Sir, is it water plus CaNO3 brackets 2?
Yeah, correct. Right. So please understand the first one is the second part is very easy. H2O, that's fine. Right. Now you are going to form the salt. Right. Now salt has to come from the metal ion and the counter anion of the acid. Okay, because this H and O will form H2O. Very simple. Right. So you are going to form a salt between the Ca and NO3, but you have to know what are the ions present. I know calcium forms Ca2 plus ion. It belongs to the beryllium family, magnesium, calcium, beryllium, all these forms 2 plus, right? And I know nitrate ion is NO3 minus. Okay, so now if you swap, right, what are you going to get? You are going to get CaNO3 twice. This is nothing but calcium nitrate. Okay, right? Very, very simple, people. You don't need to mug up anything, nothing. You don't have to mug up HNO3 plus CaO, CaNO3 twice plus H2O. No, please do not do that. That is why we spend so much time in the starting chapter. First chapter, we spend so much time just for you not to mug up the reaction. That is the entire part of learning chemistry. There is no point. There is no point in studying chemistry if you're going to mug up the reactions. Really not. Okay, that's why I tried my level best so that we did so many things so that you need not or you should not mug up any chemical reaction. Okay, one more example. Say, let me take phosphate, that is H3PO4. Let me make it react with say any metal. Okay, say magnesium. Can you tell me what will be the product here, people? Now, so obviously one is H2O, right? I want to know what is the other one. Maybe I want all of you to put the answer in the chat box. The formula of the salt that is formed here, right? Please put it in the chat box. Go for it. You know what does Mg forms? What is the other ion it is? Subscribe and get me the answer. Put in the chat box. MgSO4. It is not H2SO4 kana. This is H3PO4 phosphoric acid. It is. Oh, I think it was something else for the previous question, I guess. Okay, no issues. Okay, so H3PO4 plus Mg. I want to know what is the salt formed. Put it in the chat box. Mg3PO4 twice. Okay, good. It's correct. Mg3PO4 twice is correct. Very correct. MgPO4 twice. Almost got it. Little mistake. Yeah, Mg3PO4 twice is absolutely right. Yes, yes, yes. Yeah, good, good, good. Everybody is doing good. Great, great. I'm happy. Right? So very simple now, people. Right? I know phosphate is PO4 3 minus. This is phosphate ion. Right? And I know Mg forms Mg2 plus. This is very common. We have been using this. So put this 2 here, put this 3 here. So I am going to get Mg3 PO4 twice. That would be magnesium phosphate. Okay, so here I'm going to get Mg3PO4 twice. Okay, right? What is the time? Yeah, I think we can stop with this for today. Okay, so we completed two chemical properties. One is reaction with metals. I know metals will form metal plus acid will form salt plus hydrogen. And second thing was metal reacting with acids reacting with metal oxides. And we have to remember that metal oxides are basic in nature. And we also proved it. How do we prove it? By dissolving it in water, it forms a hydroxide, which gives me hydroxide ion, right? Or you can go for the neutralization reaction, which also proves that metal oxides are basic in nature, right? And we saw how many number of examples. Okay, now next class I'll prove it to you maybe sometime that non-metallic oxides are acidic in nature, and there are certain non-metallic oxides that are neutral also. Okay, there are something called as neutral oxides as well as something called as amphoteric oxides. All these things we'll see next class. What are these? Amphoteric, neutral, all this stuff we'll see. Okay, so I think we'll stop here today. Any questions, people? Any questions from today's class you want to ask me? Okay, fine then. We'll meet next week again. Thank you so much, people. Meet again.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you.
Thank you, sir.